Hello, gentle readers. It's December 8th, 2025. Today in Reading Foundations, we'll be just carrying on with this grab bag assortment of books collected in the study of foundations, physics, mathematics, logic, reasons foundations, a truth seeker's account. So that includes, for physics, then usually the premier theories are general relativity and quantum mechanics. So those are considered modern in the premier theories. And then mathematics has set theory and descriptive set theory, and after axiomatic set theory, that'd be in modern mathematics. So then the accounts of geometry and number theory are kind of built in that for algebra and analysis, and after arithmetic, and for function theory and topology, that all being one thing, mathematics for mathematical physics. Then logic is kind of, the classical logic, and as well kind of the modern modal temporal relevance logic, which is as well paleo-classical, dug up like an archaeology dig, paleo-classical, the Chrysippus's modal logic, and for the temporal and relations of the super-classical accounts, or the classical accounts of the super-classical, Zeno's arguments and these kinds of things. So it's a paleo-classical postmodern account of what's to result being a modern theory of mathematics and physics, and about the infinity and continuity. Then for real analysis, as after the non-standard, the extra standard, the super standard, the extraordinary, that thusly mathematics can be so equipped with the laws of large numbers, and then for doubling spaces and halving spaces according to the topology and the functions, the measurability, mensuration, the integral calculus, can then make for why physics needs that, because physics has kind of got pasted together three different things which don't agree with each other for mathematics, and two different things which don't agree with each other. The crisis in physics sometimes is called, to get back to a mathematics where continuity and infinity are natural and central and primary. And then similarly for physics, where the gravity is a force again, and in theory, and then as well that for general relativity is made for these accounts like rest exchange momentum and light speed rest frame theories that are the same, the result the same things as usual accounts of conservation momentum and the L principle, except kind of pointing inside instead of outside. These ideas of ways to consider it counts as after motion and all that, the how one might say mechanics, and then similar for quantum mechanics, it's continuum mechanics again and before. So that's just usual. That's the account here of foundations. Then is paleo-classical postmodern account, rehabilitating the broken parts of the theories today, the broken interpretations. Yeah, what were so great for them, the accounts after the severe abstraction, mechanical reductionism, to make for so why that further reductionism stacked on that is after comprehension again is not a double reductio like a deductive account making for why the limit is complete and these kinds of things for completions. Instead, it's just kind of having lost in its formalisms the necessity to bookkeep the abstractions that were already taken, since now they need to be uncovered, the Entbergung of these things. Because otherwise, it's just kind of a futile effort. It's in vain, in a sense, these kinds of things. So this paleo-classical postmodern account kind of has to get involved way beneath in the logic for the foundations, then to have a mathematics that's not paradoxical, broken, and then to get from mathematical physics that mathematics owes physics these mathematics of infinity and continuity, and then that provided, so equipping the mathematical models thereby. Then the models of mathematical physics, the physical models for the physical interpretation, and the measurables and the observables and these other usual ideas of the account for things like instrumentalism and operationalism, but really, again, for a realist account, has that the philosophy provides the necessary details of the mathematical models, so that otherwise the physical models are stuck in this perfect corner they've painted themselves into, from which on either side of the quantum mechanics and general physics corridor they stare at each other in kind of a sullen disagreement, with gravity in the middle that neither of them can say anything about at all. So that's usual account here. Foundations then, for reading foundations. So all right, let's get into these books. I saw there was one book in this box. It's JPEG. So further about the JPEG. This is the pink JPEG book. And so in a previous discussion here in reading foundations was JPEG standards. And so getting into the pile here. Here's the next JPEG book. This is JPEG Still Image Data Compression Standard, and by Pennebaker and Mitchell. So this just there's quite a bit more discussion in JPEG itself, but this gets into these different ideas for arithmetic coding. So arithmetic coding, a lesser explored, usually corner of the spec of JPEG. And sequential coding, DCT-based descriptor symbol conversion, statistical models for lossless coding, and hierarchical mode spatial corrections. These kinds of approaches that make for flow machines, the systolic and the super-scalar to implement these things. More on arithmetic coding, about the QM coder. So many of these things then would relate to like later accounts of encoding things like vector machines or large language vector machines. These are the mathematics that provide how they work in a sense. And so then when those are like, they have like this whole slew of papers. It's like, well, this is how it's all so. And it's like, well, yeah, this is how it's all so. The user's attention is called to the possibility that for some of the coding processes specified herein, compliance with this international standard may require use of an invention covered by patent rights. So that's with regards to usually the arithmetic coding. The rest of it is, as for example, from libjpeg and the library that implemented JPEG for most people on the internet, vis-a-vis various concerns like LED tools or Adobe, or professional implementations of JPEG. That libjpeg is a very professional implementation of JPEG, and the free and open source community has provided so much value to the world that it's a really quite a great and fantastic thing. So this is a book that goes very well with the standards and specifications with regards to the various processes. Baseline sequential DCT, extended sequential DCT, extended sequential DCT with Huffman and arithmetic, extended sequential DCT in 12 bits, and then spectral selection only with those, and full progression. More of the same. Lossless Huffman encoding. Lossless, extended sequential DC, arithmetic coding, hierarchical mode, and then those split out. So it has like 30 processes, but those are just kind of those different combinations of those features. So when implementing something like JPEG standards, this is a great book to have. It has some good importance. What's this? This is Learning Chinese, a foundation course in Mandarin. So I picked this up for a very reasonable price, and it's a textbook for in English for learning some of the things. Tianjin memories, Fuxi review, the character units, a geography lesson, Mei Taide, the story. I probably would have a very bad accent because I can't hear tonal differences, or I'm not just understanding how to phrase those, because a language is phonetic and tone is used for emphasis and mood. that it is very it's very tough to speak in a language where tone is syntactical, because it's evocative, and so then as also it's overloaded. Here it's figured that it's usually easier with the phonetic languages, and then for the phonemes, and then for the word roots and the phonetic and the etymological, that gets into all these kinds of things, because then the notion of the script and the written language besides is that, and those being structural diagrams and pictograms, and the ideas of the box house man chicken, these ideas of the square, and drawing the ideograms of various languages, as after the katakana, hiragana, and kana, and the letters and these kinds of things, the hangul in Korean, and then the pinyin, or otherwise bopomofo, or how the Chinese transliterations occur, and also with regards to that going back and forth from English and Chinese, and Q and Z and X and K, say, or otherwise these different ideas of the soft and hard, and the transliterations. Then for Chinese Mandarin, or Putonghua, as it's kind of entailed to be Mandarin, vis-a-vis Cantonese and Miramar, and these guys speak English. These are ideas then from getting into this is an introductory book for these things. Nijiali Yoji Kuran, how many people are in your family? Luku wa Iran Hesige Haizi, 6, my spouse and 4 children. Siga Haizi Jina Ninu, Jina Dushi New Air. So this is discussing like a conversation of families and professions. The panda, the a usual symbol after the dragon of China or China itself, the panda. Guan, manage. Dang, work, act to be. Dang Mukin, to be a mother. Dang Dushi, to work as a lawyer. Dang Gongran, to be a worker. She is frequently an alternative to Dang. Tashi Yishang. CF Taju Xiang Yi, she's in business. Dashu, chef, big chef. Probably for Dashu Shi, CF Dashifu, a more formal word for chef, Shifu. These kinds of things. Zhengtian, the whole day. CF Zhengye, the whole thing, entire, as opposed to in pieces or parts of. Zheng also appears with time expressions, as in Zandian Zheng, exactly 3 o'clock. So, it reminds me of the 3 great generals in the Chinese tradition, and they all have the same name, but they're 3 different names, and it's kind of like Zheng, but it's different. That's a cultural reference that would be familiar to most steeped in the culture. Jifi Kibushi Taman Ching Tang Jiao Jimeng Sha de Shihu Homan Ju de Shu Jiwa Eke Zufan de Sao Jifu Yishe Fandian Ming Ming. That's for sure. They work all day. When we were small, we'd have to do housework, buy the food, cook, clean the floors, wash the clothes, and help out in the restaurant. Cool, wrong. Hey, you mentioned Xing. Hey, you guys are great. No wonder you're interested in physics. Guaburi ni due uligan zinkyu. Shinkyu. It varies and it changes a little bit. And it wasn't until 40, 50 years ago that Mandarin was designated the main language of China. And there are many, many dialects. Well, and it largely Cantonese for Canton, and Cathay, and China and Cathay, and Korea, and Canton. So this is a book to learn in English and in the transliterations, at least some of the words, and then getting into things like the letters and the symbols and pictograms. Feng Shui Yuda. For things like, and then also associated with things like traditional Chinese medicine and the Tai and Tai Chi. Pearl 5 Programmer's Reference. This has been read here before. It's a great book for someone who knows the software language. More can be read from that, from like the Logos 2000 and the software and the language and these kinds of things, but also about programming languages in general. on the Revolutions of Heavenly Spheres by Nicholas Copernicus, translated by Charles Glenn Wallace. So, De Revolutionibus is Copernicus here. And so this is like spoken to in the epicycles and after the account of coordinate confluence, there was the epicycles talk, and so that was kind of addressed because that's what Copernicus did. He took the older form that had been like, well, the Earth's the center of the world, and so all the little loops of things do in the sky are epicycles. And now when the sun is the center, it's like, well, that reduced that problem, and now those are just all ellipses. Here, for example, is the southern signs, and so what's in this book includes a lot of astronomical observations. In fact, it's muchly tables of astronomical observations. And then tables. And so in the beginning, and here's the Copernican hypothesis. He says, now the reader may intuit from the following diagrams the equipollence with respect to the appearances of the Ptolemaic and the Copernican explanation of the movements of Venus. Now, in Ptolemy's hypothesis, let the Earth be placed at the center of the ecliptic, the solar cycle, and the orbital circle of Venus, which carries the planetary epicycle. Radius of the epicycle, and laid out in with regards to the sun and 100 degrees opposite, similarly the center of the epicycle, where it will appear. But according to the Copernican hypothesis, let us place the sun at the center of the orbital circles of Venus and Earth, which preserve the relative magnitudes of the Ptolemaic epicycle and orbital circle of Venus, but let us keep the Earth at the center of the ecliptic as far as appearances go, since the distance between the Earth and the sun is imperceptible in comparison with the magnitude of the sphere of fixed stars. And then where it is and where it's laid out. So that's basically the hypothesis that's put forward. So the sun, as if resting on a kingly throne, governs the family of stars which wheel around. Moreover, the earth is by no means cheated of the services of the moon, but as Aristotle says in his De Animalibus, the earth has the closest kinship with the moon. The earth, moreover, is fertilized by the sun and conceives offspring every year. Therefore, in this ordering, we find that the world has a wonderful commensurability, and there is a sure bond of harmony for the movement and magnitude of the orbital circles, such as cannot be found in any other way. So here, that's with regards to the geodesy and the world lines, that being the idea of the account of relativity and modern cosmology, that objects go according to mechanics, and they go in a straight line. And then the geodesy, all it's saying about the curved space-time is like, well, they have a tendency, according to gravity, to be changed, their directionality one way or the other. So here then the idea is that's an orbifold, and that it is, as according to all the different bodies in the system, all the infinitely many bodies in the system, is so attenuated by distance, the usual inverse square account. And for the fall gravity, implementing that, because otherwise it's given the geodesy is like, well, what direction things go? They go straight. Well, what direction then does gravity change the direction? Well, it goes down in this model of the plane. Well, what pulls that down and what lets it back up? It's like, it doesn't say, but just check it every second, every instant of time, because it has to be added up again every single time. And so then the idea of the Newton system of the world, and Kepler about the system of the world, and the eclipses after inverse square, the ellipses rather, then has that. Then the orbifold is one of these just usual inner and outer ideas, the like light speed rest frame theory and rest exchange momentum theory. Then the orbifold is the same thing as the geodesy. In terms of it being an entirely different mathematical thing, and it's from the outside instead of the inside, but yet, and its completion, in the limit, it's also as well the same thing, just like the geodesy is only in the limit, saying why the Newtonian gravity is held up, or inverse square. Has that then, this just goes to show then that for Copernicus's hypothesis, then we can also relate that to things like Fadio and Lesage for an opposite conception of gravity. The result's the same, and then when it has to be like infinite and super classical to do so, it must so be so. And so that makes a great account for why it is so. So that's part of this account from Copernicus. a demonstration of threefold motion of Earth. Yeah, the idea then that the orbifold is to help make it easier somehow to solve like the many body or n body problem, which is difficult, and it's a challenge to solve something like that because you got to integrate all things all the time, and it's in spherical. This changes, and so partial differentiation and the accounts of after analysis that make great use and employment of the partials fail because it's all lost. So the integral analysis, and then for the polar and integral analysis, and the original analysis is intended to describe then how an orbifold is a great account as for a geodesy. That this account it implements relativity theory by the numbers and by the formal methods, just a little different, but more thoroughly, and not very much so different at all, but employing Einstein's deliberations upon and distinction of the linear and rotational, or Einstein's attack on Newton, and then that has to make for mechanics itself properly, the classical mechanics. Since Galileo's account of the trajectory and parabola is falsified by spinning bodies. According to the opinion of Theo the Younger in the Aretian treatise, the stars were not arranged in the form of images for any other reason except that their great multitude might be divided into parts, and they might be designated separately by certain names in accordance with an ancient enough custom, since even in Hesiod and Homer we read the names of the Pleiades, Hyas, Arcturus, and Orion. Yeah, the names of the stars predate post-Noachic, post the flood, and the times. The names of the stars in the sky are antediluvian, and that gets into like the Atlantean hypotheses and these kinds of things. That there was a great disaster on Earth about 6,000 plus years ago, and yet those names and the words in the scripts for things like hurricane are the same on both sides of the Atlantic, and not just the usual account is after the Pacific, but the Atlantic. And the scripts are the same, and the pyramids are the same in their form, to helping explain that it's a historical account then of these things. So then there's astronomy and many tables of astronomy, and talk about the Almagest, and then that being from the Muslim Enlightenment, and a lot of these things are as of that, and then also about the great account of Muslim Golden Age astronomy that like from Star Lore, a great book, the account of the history of names of celestial objects, has that there are many accounts, and they align very much. Then the Chinese account of that is a little bit different because they kind of have the gardens of heaven or whatever it is, and so the Chinese have their own astronomy as well. It's just kind of from a different section of the sky. But it is they align up to be the same because they are all the same stars in the sky. Parallaxes of the moon on the planet Venus. This is the morning star. It's the most apparent and measurable traveler in the sky. On the positions of the anomaly of Venus, meaning it doesn't match what it says it's supposed to be. This reminds us of something like the Pioneer anomaly was like, finally the Earth, the entire civilization of humanity sent an artificial satellite, Pioneer, all the way out of the solar system. So as I was reaching that point, it's like, what's going on there with it? It's like, we're getting the reading is way off. But then when it got outside, it's like, okay, well now we can correct for it's back, and so that gets in like the Earth in the solar system in its rotating frame, and then light coming into and out of that frame, and then Pioneer is like the only experimental device made by humanity that's outside of the solar system in this theory, and so that's then a great account for that making it's not just corrections of the anomaly, it's like the effect of that. So that's what it is. Whereas Venus and its anomaly was just more of like why it is. And then about the precession of Mercury and this kind of stuff. And its appearance vis-a-vis its existence and apogee and perigee, and these kinds of things. How great the eccentricity of Mercury is, and what the commensurability of its circles is. So Copernicus, and then that was of great importance to Galileo, and then for the Reformation and Counter-Reformation of the times, the historical account, getting into why those are kinds of things. Introduction to Light, The Physics of Light, Vision, and Color by Gary Waldman. So here there's the account of after the dual tristimulus color space and light and color and the second spectrums of light and the various modes and means of emission of light, like incandescence and phosphorescence and otherwise the luminescence. And then that's explored in the color theory talks. And when I put that to the AI, as a kind of just a very cooperative, sort of thorough and large reasoner about these things, then that's what it is. So this, though, is a good account from Dover Publications of Waldman's on the theory of light. Here, it's also to be mentioned and noted that optical light, visible light, is special. And electromagnetic radiation, the usual application of light is on the electromagnetic radiation after electron physics and the infrared catastrophe, and the usual account of the photon and the electron and frequency and wavelength and energy, and then putting that all into the electromagnetic spectrum. Has light has no electrical or magnetic or nor kinetic character at all, but it is energy, and then it interacts with these otherwise systems. So that's also pretty well explored in those talks about the color theory and the other Logos 2000 bits about light, and then into theory of color. That's also addressed quite a bit with regards to emissive, and extramissive, and intramissive theories of light. So that Waldman begins with the early ideas of light, and it says Greek origins, optics in the Middle Ages, and a new beginning. So that ranges, of course, a tremendous distance. From like Lucretius's films is the theory of images, Grosseteste on light, that being medieval, to like the lens grinders and these kinds of things, and the beginnings of the technology of focus and these kinds of things. Whereas even just like a tube acts as a brief enough telescope, and then for camera obscura and these kinds of things. Getting into the classical theories, the corpuscular theory, the wave theory, electromagnetic waves, those being called classical theories. Then there's also the resonance theory, but that's more part of acoustics than after resonance theory, as to whether light is flow or flux the other way. And that's kind of the idea of the light speed rest frame theory, is like, well, how fast does light arrive in everywhere from everywhere? It's a light speed from everywhere here. It's like, well, what's this light speed rest frame theory? It's like, well, we're going at light speed, and the light is going away from us at zero. It's like, well, what's the point of that? It's like, well, it's going away at zero, but we're moving so that light is with the speed we're going. So you can say when Einstein, is one of his greatest ideas was like, I imagine myself riding the light. I'm riding the light. I am as of the wave front of a crest, of a wave of light, going at that speed, and so I can imagine being an objective observer because I'm over there, see, Einstein says. Well, the idea here is like, yes, that is always so. So that gets into why the wave theory makes for a resonance theory, and then furthermore that the light theory is a particular special thing. And then the electromagnetic waves and the notion of the travel of things in electrical fields and magnetic fields is according to O.W. Richardson, who points out, is like, we got at least three constants named C. And they're all kind of on the order of magnitude of light speed as a constant. But one belongs to electricity, another one belongs to magnetism. And they are not, according to their derivations from theories of electromagnetism, the same as light speed. But they're about the same. So we're going to call that one constant. And then these other parts, they do work out. But at the same time, the electromagnetism is more like wave velocity. And then light is a constant. Light speed is a constant. And then here that light speed is a constant, defined by the absolute, the ether, like when Einstein in his book, on the ether, or his article on side lights on relativity, on the existence of the ether or something like that, he's like, yes, there is this. It's absolute. This, my total field theory has that in it. That there's absolute space. And then the absolute motion associated with that essentially is half a light speed. Is the constant. So light speed is a constant in deep space in a vacuum. And then also light is its own constant in systems. And that way it doesn't have to be a physical constant. It's just a natural relation for a running constant. So this is how I'd express, otherwise, to Waldman's account, which is great, of getting into the theories of light, how that can be still so without breaking all the derivations that go into the infrared catastrophe and these kinds of things, while still making for it as so that things like redshift distortion, redshift bias, or dark energy, which have disproved otherwise these theories of light, making for like Finlay-Freundlich's tired light, that can't have been a constant. That still has to be so to match the data, because otherwise the whole theory is falsified. It's broken. That these are the kinds of things that make for a pretty sufficient and thorough reasoning why it is so, how it is so, that it is so, that it's the same in the limit and the same as the classical, it's the same in the modern theories, then it is better overall, because then it ends up fixing those. Modern theories: black body radiation, photoelectric effect, the nuclear atom, matter waves, manipulation of light is part 2. Optics, focus, Fresnel is considered the giant, Fresnel, or Fresnel, but Fresnel is how I'll say it. Polarization, that gets into diffraction, and the great thing about diffraction, and then the differences between the acoustic and the refraction and the diffraction, and then for refringence, as to why light is special, getting into the spectra and the second spectra, these things, after the great success of there being single lines, like the hydrogen line, and then the first sodium line, but then there's 3 of those, and going onwards for Faraday and Fresnel, the polarization, and then for Zeeman and all this great account, and then today it's back again that Faraday is back. For example, in the tokamak reactor, or these, it's found way again in these higher energy experiments like fusion, or these, or condensed matter physics. But that's because that's the only thing that's left to make for asymptotic freedom, as would otherwise be there. That's just a great thing, helping you explain why all this stuff is still in effect, and then it lines up in the middle, as long as you don't look at it from the corner, then how it can be so that it's still yet a thing. Lasers, not quite light. Lasers are a radiation. They're a beam, of course, and it talks about the cavities, and the notions of cavity and resonance out of the cavity is what builds these things in effect. And so it's like the other day there is like a great account of like, well, the new physics has got the stuff that it's like all about resonance theory, but it doesn't say so. And it's like, well, what's the experiment? It's like, well, it's got a cavity resonator, but it doesn't say so. And it's like, well, that's how microwaves work. That's how lasers work. All these kinds of things are built like this. So holography. Now, holography gets into a bunch of different things from the different matters perspective, and the fact that light can cross without interfering with itself. That's another great important thing about it. The eye. Here's been talked about the fact that for the stoma of or of the bee's eye and the frog's eye, and then the mammal's eye, and then for it being round, and the eyeballs, and so that then the parallax and peripheral parallax are things that that's different than flat screens and cameras. It's different. Yet at the same time, it projects onto those. That light is optical, and light is special. Optical, light and color in nature, rarely scattering. The usual reason given for why the sky is blue. White light scattering. Dispersion, coronas and the glory, and then about like the coma, the aberrations of optics are called, which and they can't be illusions though because you can see it, so it must be a feature of optics. Other natural lighting effects. Here it reminds of reading from Rude, the modern chromatography, chromatics, and then for the chromatic and prismatic here, kind of for the dual tristimulus color space. Color science, Newton's work, primary colors, attributes of color, color imagery, lens and mirror equations, Snell's law. So you got Snell's law, and then later there's like Beer's law about using light and rays in medical imaging and these kinds of things. Because the X-rays are a lot more like optical character than electron beams. Because furthermore, about the electromagnetic radiation, that electrons don't observe diffraction the same way. They just don't. And so it can't be said they're the same. Although, and then certain ways to carry the electron beam or so, it kind of does, but that's because it's a carrier wave. And so these are the things, getting into why this book is perfectly suitable for its placement in a modern account. But in our postmodern and nouveau modern account, it's also an example of a reference to that time, in those times. Dictionary of Artificial Intelligence and Robotics by Wiley InterScience. Rosenberg, editor. Dictionary of Artificial Intelligence and Robotics. John Wiley and Sons. Jerry M. Rosenberg, Ph.D., Professor, Graduate School of Management, Rutgers. 1986. Dictionary of Artificial Intelligence and Robotics. Significant research and interest in research in artificial intelligence and robotics began only 20 years ago, but in this short time span, an entirely new vocabulary has been born. Major objective of artificial intelligence is to make machines smarter. Secondary goals include understanding what intelligence is and making devices more useful. Then gets to robots. This work of more than 4,000 terms has been prepared with the hope that awareness of the accepted meanings of terms may enhance the process of sharing ideas. Though it cannot eliminate the need for the user to determine how a writer or speaker treats a word, this dictionary shows what usages exist. It should reduce arguments about words and assist in stabilizing terminology. Most importantly, it should aid people in speaking and writing with greater clarity. A word can take on different meanings in different contexts. There may be as many meanings as there are areas of specialization. A goal of this dictionary is to be broad and to establish core definitions that represent the variety of individual meanings. My purpose is to enhance parsimony and clarity in the exchange process within the fields of artificial intelligence and robotics. This is a defining work rather than a body of facts, the author puts it. So looking into this a bit, here's like ANSI, they make standards. Anthropomorphic, human-like, or able to duplicate human traits. Or anthropomorphic is one thing, but to anthropomorphize something is to assign otherwise human traits. It's like Conway's law of organization or whatever it is. It's like somebody's pet ends up looking like them, and vice versa. And so Conway's law is like, well, the system reflects the organization, and vice versa. And so anthropomorphization is like, it has human-like characters, or I think so, and vice versa. That's just something you mentioned out. And those are basically matters of presence, consciousness, and activity and reasoning, and however that may so be. APL, a programming language, arithmetic logic unit, computer terms. Here we read that one great dictionary of computing, and so that this would sit well on the shelf right next to it. automation, auxiliary memory, data code, an octet sequence or character stream, data file, a collection of related data records organized in a specific manner, data filtering, data flow chart, data flow diagram, data item, data link, data memory, data object, data set, data structure, data tablet, a flat surface graphic input unit used with a stylus for inking and cursor movement. The usual idea of a slate or a tablet. Data terminal equipment, data word, database, data channel, data digital control, data break, data bus, data cell, data channel, data code. Zones, trees, degrees, deep knowledge, knowledge of basic theories, first principles, axioms, and facts about a domain. See also experiential knowledge. Deductive inference, in formal logic, the derivation of a logical consequence from a specific set of premises, a truth-preserving transformation of assertions. See also deductive inference rule. See inference rule. Dendral, an early rule-based expert system that assists in determining organic compound structure utilizing data from mass spectrometers and nuclear magnetic resonance devices. See also metadendral. Storage, range, edit, effective address. Forward chaining, a control strategy that regulates the order in which inferences are drawn in a rule-based system. It begins by asserting all the rules whose if clauses are true, then checks to determine what additional rules might be true given the facts it has already established. The process is repeated until the program reaches a goal or runs out of new possibilities. Synonymous with data-driven. That's also considered part of a flow machine, but because the inferences might later be added, it has to have all the facts have to be fixed at once, because otherwise there can only be derivations, because otherwise they might contradict each other, and then it ends up with the usual fallacy material implication that first C rule won, but then the last rule wins, and they can be different. And so even after the quasi-modal account, then taking the inference rule together, it's like, well, okay, now just take the union of all those. It's like they still can't disagree. You gotta make it so this is just like, just get it done, one pass. Then the idea of the wider, fuller account is like it's got to be read in every possible different way, and so determine all those possible relevancies to each other, and in the completions of it is part of the greater deductive account. And so that just goes to show that then it would be limited by a system, and otherwise if people didn't say, well, that couldn't possibly go wrong, computers are never wrong, or they never lie, or something like that. It's like statistics will lie if you let it. And quasi-modal logic is not modal logic, and it does not have monotonicity nor entailment, except as facts of what it could say about itself that are incomplete. So here, of course, that's addressed quite thoroughly in these other talks. Frequency response, adders, subtractors, functions. Human information processing, an interpretation of human thinking that is influenced by how computers work, focuses on the information that an individual uses to reach a conclusion, and then asks how one could design a computer program that would begin with that same information and reach that same conclusion. Well, there are ways and ways. And then it could be said that they model each other only in that particular act of inference and reasoning, because it doesn't say how they would think about any other thing that's not the same thing. But it's an idea of establishing that it's like it's so, vis-a-vis it's not so. The other day I was thinking about this, the differences in linguistics between the words but, as in this would be so, but that is so. And they disagree, so they can't both be so. And yet, this is so, yet that is so. And so it fills in the same purposes, the word, showing then the land of ex falso quod libe, that both of them would be so, and then for tertium non datur, that neither of them could be so, or one or the other of them must be wrong. Then the yet is instead is like, this is so, yet that is not so. Like, it is so that it is raining outside, and that usually at this time of year, that would mean it would be snowing outside because the temperature would be colder, 10 or 15 degrees. Yet it is not. And so to say that it's like, thusly it will not snow as long as it's raining, is different than saying, so thusly it will never snow. It would snow, but it's not now, and so it won't. So this is why there's no but, only yet, in a proper modal temporal relevance logic. And so then getting into the linguistic logic of that is the difference between not but and not yet. Because you'd say something like, well, this is not but a sprinkle vis-a-vis a rainstorm or something like that. It basically removes the relevance to the other term that it can't acknowledge exists, because it's just not so at this time. And so this is not yet a rainstorm, yet a sprinkle. Is the idea being that but and yet are similar and alike, but and not yet are kind of opposites. Because the one's reflecting the land of tertium non datur and a fixed closed world. And the other one is including that also as well, the idea that things change at all. So that just goes to show that anyone never needs to use the word but for the rest of their life. They could always use yet. And so like in Francais, it's like mais. Ce serait si, mais ce ne serait pas. This is so, this would be so, but this would not be so. I'm not sure the word yet on yea. Depuis, maybe, or since, during, and these kinds of other modes of the temporal would be so applied to explaining for the linguistics and logic. That's just a little note then, helping explain why the entailment and monotonicity are parts of a real modal temporal relevance logic, and that's always available, and so common sense is always satisfied, and direct implication is true, and De Morgan's laws hold. And all these usual kinds of things. Identity operation. Identity, equality, and tautology each kind of end up looking kind of the same. They mean like not different, the same. But then there are three different things with regards to the extensional and intensional, explaining how things like, as for example, mentioned the example of a model inference, may be so for an example, then is whether they apply more generally, and figuring out the generalities of these things. That without loss of generality is sadly one of the most misunderstood and wrongly used terms in mathematics, because it's a wish sometimes as much as a lemma, say. Knowledge representation, a means for encoding and storing facts and relationships in a knowledge base. Semantic networks, object attribute value triplets, production rules, frames, logical expressions are all ways to represent knowledge. So, of course, those are all state-of-the-art and have been so since 1986. So there's nothing new in that world, and plenty old wrapped as new. Except the embarrassment of riches of the resources of all the computer chips and the micro-miniaturization combined and multiplied by the data center follies and stealing all the juice from all the electrical systems everywhere to compute better bananas or whatever is the latest greatest thing about it. That this is old hat, artificial intelligence, these terms. And the systems these days are basically just like taking a simple thing and haven't blown that up huge. But yeah, instead of large language models, that small language models can still be very completely effective in means of inference. And with regards to the knowledge base and the store of knowledge representation can employ that in their own ways. Prospector, an experimental expert system intended to help geologists interpret mineral data and predict the location of mineral deposits. All right, protocol. This is good because I've been looking for a definition of protocol. I'm working on writing some internet protocols, implementing some protocols. And also with regards to the notion that these days computers in their central processing units are like a bunch, like tens and dozens and coming to be hundreds of individual cores. And then with non-uniform memory access, it's like, well, it used to be like a node in a computer was just like the CPU, the RAM, and the bus, one of them. And now it's like it's a distributed system itself. It's a self-contained distributed system. And that's without talking to things like people wanting to, RDMA, the InfiniBand or whatever, and otherwise, connect that stuff and what's the word? Making that so it's not a self-contained, closed, distributed system. So the design of an operating system these days kind of has to be to design it as a distributed system, because otherwise it gets into the reasons why when designing a distributed system on a network, they like the internet or using these sorts of usual accounts, that its protocols would either be so or not so, and the asynchronous concurrency for the synchrony and the concurrency means that it has to basically be treated as a distributed system of each one of these computational units of its own closed thing. And then with regards to the matters of concurrency and synchrony, and that is formally asynchronous, all the interactions. And then furthermore, that the ideas and issues with Moore's law and Murphy's law put together will make for so that to be a self-healing kind of system and eventually consistent. And otherwise, these ideas to prevent bottlenecks and otherwise a parallel, that the traditional operating systems are designed to be what results kind of a bottlenecking of these. And so the hypervisor accounts are intended to be like, well, we'll just split it up and make it embarrassingly parallel, and so that we can run 128 different applications on these 128 different nodes, and each one will be their own thing. But then trying to get them together again and the challenges of parallelism and vis-a-vis the super-scalar and the heterogeneous workloads or varying workloads vis-a-vis the constant rate and constant time, the embarrassingly parallel and linear speed up, and these kinds of things, and employing the resources has that the protocols is a key thing there again, because protocols is how distributed things communicate. It's matters of communication, and for what state machines there are of each other. And so sometimes people say, what's a protocol implemented as? It's like, well, it's a grammar and a state machine. It's like, okay, what about both sides? Isn't that two state machines? And then aren't the grammars essentially open? And so then there's two state machines, and with all these implicits and explicits, like when the link drops or anything along those lines, when there's a drop or a duplicate, or anything else that could go wrong with it. And then it's like, well, yeah, I guess that is two state machines, but now it's one again. So this is the monad from the functional programming languages, and the pure function of the entire thing, and the monad is from languages like Haskell and stuff like that. At the same time, that's unattainable, because that just fills the entire space of all time with all the data. And essentially, at some point in time, the memorylessness is a benefit, not a disadvantage, because it costs to maintain memory. And so then trying to figure out how that goes with protocols is into the design and implementation and the definition of what a protocol is and what meeting a protocol is. That then basically that's divides down to atomics, and this protocol is all the way down. It's kind of the idea. Because then anything above that is undefined. So what is the primary protocol? What is the protocol? Protocol 1, a specification for the format and relative timing of information exchanged between communicating parties. And this is where it's like they have models of information. So yes, it is that. The information exchanged. And it's information because otherwise it would be just not information, meaning it's like nothing was sent. So that nothing is sent is also information itself. Whether that's relevant to eventually the disposition of the data and the information exchange of these protocols, that is in communication and in exchanges is the idea. Then it has that exchanges are kind of this atomic act of protocols and communications itself. And then with regards to what that means to the state of information, the model of information. Definition 2. The set of rules governing the operation of functional units of a communication that must be followed if communication is achieved synonymous with line control discipline, line discipline. So that reflects on like serial protocols, and then also that's part of the overall critical transactionality of things and synchrony in these systems that have asynchronous concurrency by design, and as a matter of fact, that this is kind of thing protocol, what that's to be. Prototype. So the words, in regards to the word in the linguistics, the word protocol, I was like, well, it's a protocol, and then it's like the colophon, and so it's like I'm wondering what a colophon is, and the way it relates to like that is the way to connect it to other matters of information is a colophon. I don't imagine that's going to be defined here, but it does exist in the wider dictionary. Collator, color, column, binary. Collate, codes. Protocol. Language processor. Large hybrid system building tools. A class of knowledge engineering tools that emphasizes flexibility, designs for building large knowledge bases. They include a hybrid collection of different inference and control strategies. Most commercial hybrid tools incorporate frames and facilitate object-oriented programming. Incorporate frames. Frames in this sense of transmission is like packets and frames, and segments and packets, and the nesting of data within data, tagging of the data. That is then an individual unit amount of data. So just looking then for what frame would be so considered to be defined at the same time. Well, there's expert system, of course. Expert systems is AI. Fail fast. Forward chaining. Frame. A knowledge representation scheme that associates an object with a collection of features, e.g. facts, rules, etc. So these usually be the tuples and the relational tuples of the triples, usually, like of resource description format, an OWL and these kinds of things. So each feature is stored in a slot. A frame is a set of slots related to a specific object, similar to a property list, schema, or record. So about attributes, elements and attributes, or records and attributes, which are used in conventional programming, synonymous with object, unit. So if a frame is matters of relation. So here the author has is like synonymous with object, meaning that's a relation. A relational database table is a relation. A unit is like, well, it's a scalar. It's an instance of a struct. It's a relation. So then this frames is a set of these relations, but it doesn't say all of. But it just says a scheme that associates an object with a collection of features. So, arithmetic, logic, programming, programmer's apprentice, a system for aiding programmers by maintaining track of decisions, recalling program skeletons, automatically testing revised programs, supporting natural language interaction, and translating to and from various program representations. Programmer's apprentice. These days, it's kind of the way around. Proprioceptors. In robotics, a component that senses the posture of a mechanical manipulator, legs, or other jointed mechanism. Property list, properties. Attributes would be the other idea usually. That's with regards to attributes, aspects. This was considered a bit more in the software talks here. This is with regards like to the mental machinery. Attribute, the property of an object. For example, net worth as an attribute of a loan applicant. Attributes are associated with values in specific cases. See also descriptor. So yeah, descriptions and descriptors are all these matters of relation and this kind of stuff. So this is a good little book from 1986. There's nothing wrong with it today. Implemented on a much wider, larger scale. Well, we come to an hour here today. This is a book. Sometimes you get a book from somebody, and it's intended. It's like it's borrowed. This book is essentially borrowed. I was on a trip with my friend to California, and we went to visit her friends, and then one of her friend's brothers had this book, and we had a conversation about stuff like Ray Kurzweil's The Singularity is near. This is kind of an apocalyptic account. It's kind of like Eliezer Yudkowsky's ideas, like AI is an existential threat. It's like, yeah, well, hasn't it always been? And then so anyways, this book is on loan, but it's a good book, and it explains a lot of things about technological advancements. So Kurzweil's The Singularity is Near is definitely very, very influential. Well, all right then, gentle readers. Happy holidays, Merry Christmas, as it may be. Season's greetings. Happy Hanukkah. Ramadan is it's either kind of a month or before or after, oftentimes, or right in the middle of New Year's. And then there's New Year's, then Lunar New Year's or Chinese New Year's. Winter time is here, and so if it was 15 degrees colder today, there'd be about a foot of snow here, and that may so be the case because it's supposed to rain for the next foreseeable future. Yeah, it won't always rain. Hey, have a great day. Goodbye.